Good morning, students. In the last class, we discussed about the functions of the basics of the functions. So I hope that it is clear that how a user-defined function is declared, defined, and called. It is also clear that what is the meaning of return nothing or something like this, return something. All these words are clear to everybody. Today we will talk about the scope of the variables and the storage classes. So first of all, scope of the variables. So what does the scope mean? So there are two terms which are used mostly in programming. One is lifetime and second one is the scope. Just go through the text which is written over here and then I will discuss it. Basically, lifetime is the complete life till which time it remains in the memory. While the scope of a variable is basically it is a subset of the main lifetime. After the scope, the variable may remain in the memory, but you won't be able to access it. It will remain in the memory, but you are not able to access it. Then there are two types of scope, basically three types. Most commonly used are two ones. First is local scope, when a variable is defined within a function or a block, then it is locally accessible within that block and hence it is known as local variable. So here we are talking about the brackets, curly brackets if you remember. This curly bracket, if I am defining it is equal to 0 here, then this is the local scope. Global scope means if there are multiple functions, say I am having one function int f1, then I am having int f2. So I want to use the same variable here also. Then that is known as the global scope. So in that case, we want this variable to be declared outside these functions. So that type of variable is known to have a global scope. And this variable is passed as formal argument. Formal argument means what? If you remember in the last class, we have written one function where it was add in the main part. We were having add. Here we were giving some arguments and in the function we were having these variables and we were having something like this. So in this case, these arguments which are there in the main program are known as the actual arguments. And these are known as the formal arguments. And these formal arguments can will only survive within this function, not outside this function. Read this text. When it is declared within a block or a function, then it is known as the local variable. When it is defined outside the function, and then it is known as the global variable. This is very important. What does this mean? We will talk about this. Wait a moment. This is about the initializing the. If we talk about local variable, when a local variable is defined, you have to initialize it. You have to initialize the value. Otherwise, what it takes the garbage values. But if you declare a global variable, then these values are the default values, initial default values in the case of global variable. So basically, it is 0 in all the cases. Now, taking one example. Wait. I will take another PPT. Wait a moment. Is the screen visible?
Yes, ma'am.
You're able to see Dev CPP?
Yes, ma'am.
Okay, fine.
No, ma'am.
Font size is
Very small. Wait.
I'm not able to see screen, ma'am.
Wait. I will share it again. Now is it visible?
yes, ma'am.
Okay. So if we are having this type of program where you can see that a variable is declared here, G variable is declared here, this is the global variable. Why? Because this is outside the function. Okay, so it can be used within main function as well as another function. Okay, for example, if I write one more function here, then it can be used over there as well. Okay, so is the cursor visible?
Yes, ma'am.
Okay, so we have different functions in this case, right? So when you're declaring this variable outside the main function, then it is known as a global variable. And as we have already seen that the initial value of the global variable is initialized to 0 in case of integer. So this G will have the 0 value initially. And these are the variables which are defined within the function, and these are known as the local variable. So in the case of local variable, you have to assign the value, and then only you will be able to give the output. But now here you can see that G is having an initial value of 0, but when you assign the value of A plus B to G, what should be printed on the screen? The value should be the addition of the 2. So let's see the result. So if you see here that it is having A is equal to 10, B is equal to 20, and G is equal to 30. Is it visible?
Yes, ma'am.
Yes, ma'am.
Okay. So why G is equal to 30? Because here we have re-initialized the value to A plus B. But if we don't use G here, instead of G, if I use C here, say, and what I will do, I will declare the C variable here, and I will print instead of A, B, and C, I simply print A, C, and G. What happened? G is 0, as you can see, right? And B is having 30. Why B is having 30? Because I have not changed this one. So now C is having 30, but G is having 0. So the global variable is the one which is declared outside the function. Okay. Here is the example of the question of the sentence that we were discussing, that the local variable and global variable can have the same variable name, but they have different scopes. Within this curly bracket, red curly bracket, G will have the value of 10. Okay, but outside this curly bracket, G will have the value of 20. So if you try to print it over here, then it is going to give you a value of 10,
Ma'am,
not
previous slide,
20.
please, ma'am.
Previous slide, this one.
Previous. Yes, ma'am. Okay, ma'am.
In this case, if I try to execute it, that value of G is equal to 10, right? Why? Because it is within this one. And the third example, here we are trying to use a function also, a global variable A also, and the main function also. So within main function, we are defining A, B, and C. So you can see A is used here as well, here as well. We can use. There is some question. Yes, I am explaining it again. Wait. This one is the global variable which is defined outside the functions, and the same variable name can be used here as well, where you are defining some other value. Okay, just read the program once what it is doing, then I will explain. I will take a pause for 30 seconds so that you will be able to understand. So here you see what we have written is, this is a global variable A, and this is a local variable A, and this is local variable B. Then we are trying to print the local value of A. Then we are assigning these values of A and B for a function which is known as a sum function. Here these values are taken as A and B, and here it is printed as A and B. So now we have to see what is the effect of the global variable and the local variable. As if you remember, what I said is, this A can be same variable name can be used at both the places, but the local variable will remain active within the block. So where is the block? This is the block. So within this block, this A will have a value of 10, not 20. Outside this block, it can have any value. Similarly, when we talk about the formal arguments, they have their value within this block. So the value which is assigned to A here, A and B here, will remain live up to this point. Okay. So this way, if so in this case, what should be the value which is printed for A, and what should be the value for C? I'm talking about the main A and C.
10
10.
for
Yeah.
A.
And what about this A and B?
For that, A would be 20, ma'am.
Let's see. What are the values? In the first case, A is having 10 because of this local variable. A in sum, because just after coming to printing this value, it goes to sum. Where is the sum? It directly grows from sum AB to function sum. Within this sum, we have already sent the value of A as 10. Which value? This value. How we have sent? Using actual argument. So now this A is having a value of 10. Okay. So if A is having a value of 10, so what will be printed here is again 10, not 20. Right? And B will have the value of 20. Right? Why 20? Because it is also passed as argument. Okay, this is known as the call by value. So we are passing the values, right?
Ma'am,
Yes.
so ma'am, further for any such thing like sum or any such thing, so it will continue to be A equal to 10 only then.
Within this bracket, it will be A is equal to 10.
Okay, ma'am.
I will come to that point. Don't get confused. I will come to that point. I will take one more program, then it will be clear. So, is this thing clear that within this curly bracket, local variable has higher priority as compared to global variable? So, whatever you have assigned as the local value will be used within this bracket, not the global value. Okay, and similarly, what will be used within this bracket will be treated as the local value. Why? Because we have sent these values as formal arguments, right? Okay, so coming back to our PPT, so I will stop sharing this. So now I hope this thing is clear to you. What is written over here? That we are having a global variable G and we are having local variables A and B. So if we are assigning the value of A plus B to G, then its value will be changed from 0 to something else, that is 30. Right? What should be the output in this case? Global variable declaration is here, and here we are having printing the value as G. What will be the
Equal
output?
equal to 10.
Yes, G will be equal to 10. Correct. This is the program we just discussed. Now coming to the storage classes. For storage classes, first of all, why we need so many classes? Here we will be talking about these 4 storage classes. We will talk about these 4 storage classes. First is the auto, second is register, third is static, and fourth is external or external. Basically, when we talk about any storage class, what is the meaning of storage classes? Basically, how you are storing this in the memory. You know this thing that all the data is stored in the memory. Say, if I am declaring a variable x is declared in the memory. So, where you are storing and how you are storing, what will be the properties of this stored data? So for defining the properties, we have different storage classes. What are the properties on the basis of which we can decide which storage class to be used? These are the first three properties which are very important. What is the name of the variable? What is the size of the memory, and what is the type of the content? For example, if I write int x, then you all know that it is of which, what is the name of the variable? This is name of the variable. What type of content you are going to store? You are going to store some integer value. And what is the size of the memory? You know from this that either 2 or 4 bytes depending upon your compiler. Okay, these are the first three properties, but we also require 4 more properties along with these three properties. What are those 4 properties? So those 4 properties are default value. What is the default value? Means if you are not giving some value, what value is stored? Then what is the storage type? Then what is the scope? And what is the life? What does these all things mean? We will talk about them one by one. If we talk about auto is auto type variable. When you are writing simply int x is equal to 4, then it is auto type, because if you are not writing anything before int, then it is automatically taken as auto type. What does this auto mean? It means that its default value will be a garbage value, means any random value will be there. Where it is stored? It is stored in RAM. What is the scope of this variable? When you're defining a variable as auto, then the scope is limited to the block in which it is declared. And what is the life? As you have read the definition of life and scope, till execution of the block only. So means life and scope both are within that block only. So if we see this program, int x is equal to 5, this is declared as local variable within the main program, printf x. Then there is one more curly bracket, then I am defining int x is equal to 2. Then what should be printed here?
2.
Whether it should be 5 or 2. Don't know. Okay.
2.
Wait. I will show you. Are you able to see this one? In this case, simply I have defined this int 5, x is equal to 5, and we are trying to print this same value. Then within this bracket, we have defined x is equal to 2, and then we are trying to print it. So what should be the value within this curly bracket? This value of x will be there. So 2 will be there within this curly bracket. But outside this curly bracket, you will have the value of x is equal to 5. So the first printf statement where x1 is to be printed, you will have the value of 5. For the second printf statement where x2 is to be printed, you will have the value of 2. And for the third one where x3 is printed, you will again have the value as 5. Because we are not making any change in the value, and value of x will remain 2 within this block only. Outside this block, the another value will be used. So what will be the result in that case? It will be x1 is equal to 5, x2 is equal to 2, and x3 will again be 5. I hope this is clear to everybody. So auto means it will have the life within that bracket. And let's see, if I am not defining it, what happens? X1 is equal to 0. This is taking the default value as 0. Okay. But what is said is, in the case of auto, the default value has to be garbage value. But in Dev CPP, we have seen that default value is given as 0. Right? So coming back to our program, this is your register auto type. Second type we will talk about is the register type. In the register type also, the default value is set to be garbage value. Storage now in this case is in register. Again, it is limited to the block in which it is declared, but its life it is till the execution of the block. So in this case, what is the difference between auto and this one? I will explain that thing. Basically, register is, if you see, this is your memory. And here you have your CPU, or where processing is being done. We have a few registers. They are named as R1, R2, R3, and so on. Or they are also known as A, B, C, D, E, F, HL. Okay, so we have a few registers here. Many times what happens, when, for example, when you declare a variable x, which is of auto type, definitely that value will be in memory. So whenever you need to execute something, you will bring this value over here, and then after execution or making a change, you will store that value here again and again. So it requires some time, which is can be set to be t, say 10 nanosecond. Now what we want to reduce this time. For example, it is very simple when you are having a program of 4 lines, but when you have to use x, say 10,000 times in an hour, then 10,000 into 10 nanosecond. So it will be a time which may cause delay. So we want to reduce this time. How to reduce this time? So what we will do, instead of storing it in the memory, we will shift this value over here in this register. Now this time will be reduced. Say t time was required earlier, now t by 10 time will be required, say. So you are reducing this time requirement. Okay. Otherwise, auto and this will work the similar. There won't be any difference in the working in both of them. Okay. So this is the difference. If you see this program, then it is the same program in main. Here we have written, we write it like this: register int x is equal to 5, int y is equal to x plus 5, x plus plus, int z is equal to x plus. So you can see you are using x again and again. So to reduce the time of bringing that again and again memory to CPU, we are storing it in the register itself. But that will be an intelligent decision to make that which variable should be kept in register, because we are having limited registers only. Number one. Number two, even if you make this as register, and for example, these registers are busy, for example, there are 4 registers only, all 4 are busy for some work, then it will not be assigned in the register. Then in that case, this will automatically be converted to auto. Okay. And you may not be aware of that thing. So it is not compulsory that if you have written register, that it is going to register only. If it is only possible if the register, any of the register is free, you will be assigned register. Otherwise, you will be assigned auto. Right. So this is about the register one. Going to the third one, that is the static one.
Ma'am,
Yes.
may you please explain the top diagram again in the last slide?
Yeah, I will explain. Wait. Basically, what happens that we all know that this is the memory space which is available, and this is the place where processing is being done. Whenever you want to execute something or you want to process some data, say I'm writing x plus 5. So this is processing. Where this processing will be done? This processing will be done over here in this block. But your data is lying here. So what you have to do, you have to fetch that data from this location to this location. Isn't it? It requires some time which is very less as compared to our timings. Say it is 10 nanosecond, but according to the requirement of the CPU, it is too much. So it requires, say, this much time. Again, you have to send this back to the same location after the execution. Say you have written x is equal to x plus 5. So what you will do, first of all, this x will be fetched from memory, and this is in your processor, and then again it has to be sent to memory, right? If this is to be done 10,000 times, then it will require a considerable amount of time. So we want to reduce this time. So what we will do, we will keep it here itself. It is something like that. You when you were preparing for JEE, then you were having one book which you had to study daily. Say 4 hours you are studying from that book. Okay. Can you name any such book, any one of you,
Short
which you?
notes type, ma'am.
Yes. So you were required to read it daily. Where you will keep that book? On your table, in the shelf, or in the cupboard, or maybe in some other room where you will keep that book.
Table.
Definitely you will keep on the table. Why? Because you require it again and again. But is it possible that you will keep each and every book on the table? No, it is not possible. You have a limited space on the table. So what you will do, you will keep only important items over there which you require again and again. Same way, we have a register here where you will keep only important items. So it is not only used for storing the variable, it is used for some other purposes also. And we have limited free empty, then you can keep one more book. But if it is no space is there, then you can't keep that book. Same way, here also you can store a variable only if the register is free, so that you can save your time in bringing that book from the shelf again and again and keeping it back in the shelf. Right? Same way here also. It is the same thing. That's it. I hope this answers your question. Any other doubt?
Got it, ma'am.
Yeah. Okay, fine. Some other question is also, may we use printf outside main function for printing global variable? You try it on your own and see. Atharva, you try it on your own and see if it gives you the result or not. Okay?
Yes, ma'am. I will try.
Good question. Good question. So basically, now the third one is the static one. In the static case, we have a few changes. What are the changes? First change is default value is 0. Second change is it storage is in RAM. Sorry, storage earlier was in RAM as well. Limited to block in which it is declared, and life is till the end of the program. What does these two things mean? Here is a program written over there. What does this program mean? I'm defining one function f1. Simply I'm calling it two times in this main. What is that function? That function is void f1 and no arguments are taken. Simply it has int I is equal to 0, I plus plus printf I is equal to percentage d backslash n and the curly bracket closed. What this program is going to do? What it should do? We have defined I within this function. Okay, so it is initialized to 0 whenever you come within this function, that it increments the value by 1. So I will be changed to 1 and 1 will be printed. How many times it will be printed? 2 times, because 2 F1s have been called over here. But I want to make a change in this program. Okay, I will show you. We will go to the again. Yeah, static one. Yeah, see what it is giving this program. It will give you 1 1. Why 1 1? Because every time whenever you come within this function, it is initialized to auto and it is initialized a value of 0, and so it will give you a result as 1 1. But simply what I will do, I will write static here. Now it is of a static type. What this static says, if you remember, it said about that the default value will be 0. It is stored in RAM. The scope is limited to the block in which it is declared. So it will be limited to this block only, right? But its life is till the end of the program. So what change this thing will do to it? See, I is initialized to 0, I plus plus will make it 1. So 1 will be printed, but now this 1 will remain in I. It is not going to be initialized to 0 again. Okay, so when you call the function f1 again, it will use the value of I as 1, not as 0. Okay, and then I plus plus will convert it to 2 and 2 will be printed on the screen. Okay, so that is the importance of static. So if you want any variable in any program, so that whenever you call the function, it should start from that position itself. It should not be initialized to 0 or initialized to 1. Then in that case, we use static. For example, if we are assigning roll numbers to the student, for example 30 students have been already been enrolled, so the next roll number should start with 31, not with 0. So in that case, we will declare it as static one, so that the next one will be considered as 31 only, not as 0. Okay, even when you're running it again or when you're using that function again. I hope this thing is clear to everybody. And the last one, that is the register one. No, not register, external one. External storage class. What it is having default value is 0, RAM. In this case, it is global. And life is till the end of the program. So how this will work? Say I will take this one again. If I am writing int x here, main printf, x is equal to percentage %d, x f1 printf, x is equal to percentage %d, x, then void f1 x plus plus printf, x is equal to percentage %d, x bracket close. Now let me know the values. I will name it as x1, x2 and x3 for ease. Now I want the answers in the chat box. What should be the value of x1, x2 and x3? Basically, if I tell you the concept of the external, basically it declares a global variable. You know the concept of the global variable. So whenever you declare it as a global variable, then automatically it is considered to be a external class. So what should be the value of x1, x2 and x3? I want answers in the chat box. Till that time, I will show you the results in the So what's the answer? I will share the screen. This is the answer. 0, 1 and 1. Why? Because initially it has taken the global value. So it has taken 0. Then it goes to function. In the function it is incremented by 1. So the new value will be printed as 1. And then when it goes to the main program, again it is printed as 1. So you can see that in this case global value is having an impact. So somebody who was having a doubt that outside this bracket what will be the value, so here you can see it is going on changing or incrementing the values of the same variable when it is moving from one function to other function. Okay, so this is the fourth storage class, that is known as the external storage class. If you have any doubts till this point, you can ask.
Ma'am, I am not able to understand X3.
Which one? X3. Because in this case, what will happen? First value, say this one. This one will take the global value. What is the default value here? It is 0. So as soon as it comes inside, it takes the value as 0. Right? So 0 is printed. As soon as you come here, F1, you know that as soon as function is called, what happens? It goes to the function immediately. So it will go to this function, and within this function, what will happen? X is equal to x plus plus. So the value will be incremented by 1 because it is having a life till the end of the program, and it is a global variable, right? So it is not limited within the program, it is already declared outside the function, not within the function, but outside the function. So when you click x, write x plus plus, its value, this variable's value is incremented by 1. So now this x is having 1. So when you print the value, it will print 1, right? As soon as this is closed, where you will go? You will go to this function. So what is the value of x right now? It is 1. So what will be printed here? It will print 1. That's it. Is it clear now?
Okay, yes, ma'am.
Anybody else who is having a doubt? Okay. Then we will close the meeting for today.
First will be printed x1, then x3, then x2, है ना?
Yeah, yeah.